Hi everyone. I thought I would go over some chapter 6 stuff just so that you guys can refamiliarize yourself with that before you take your test. If you need to take your test again, I'm going to be resetting everyone's tests. You can take, I'm sorry, not resetting, but enabling 2 attempts for the test. So hopefully this will help you. Please make sure that I know that there's 2 days to get it done, but it's a very short test and it should be done by then. We've gone over this a lot in class, so hopefully this will um, bring back some memories. A lot of this stuff should have been done before break, but I'm going to go ahead and go through everything on how to use the calculator, and hopefully that will help you all. Okay? So just basics about a normal distribution. Remember, a normal distribution is symmetric about the mean. It looks something, oh, well, pretend it, no, let's redo that. Let's see if I can make it look halfway decent. Okay, so that's kind of, all right, so it's symmetric about the mean. The area underneath the curve is 1. And basically it never touches the x-axis. And remember the empirical rule, 68, 95, and 99.7. The other thing that we need to remember is our formula for a z-score. So remember, your z-score is your x value minus the mean divided by the standard deviation. We're going to be doing that every time we create these, do these calculations. If you just put in the mean and standard deviation that's given to you in the problem, you're going to be off with them. So you need to go back in and make sure that you're calculating the z-scores for all of these, or else you're not going to be completely on point. Okay. Also, as a general, go ahead and try to go to 4 decimal places here. So hopefully that will help. So find the area under the standard normal curve between a z-score of 0 and a z-score of 0.98. So what I'm going to do is go ahead and, oh crap, let's see. So I'm going to do second VARS, and I'm going to go under normal CDF. Okay. Our lower z-score is going to be 0, and our upper z-score is 0.98. And we run that through, and our value is 33.65. Okay. All right, so we're going to do a couple more of these. In between z and negative 2.4. Remember, negative z-scores, if we look back at our z-score, or our normal curve, negative z-scores are here to the left of the curve, and positive z-scores are to the right. So you always, the more negative something is, the less it is. So this is going to be our lower bound. So we're going to do this again. Second VARS and normal CDF, not PDF. Okay, our lower bound is going to be negative 2.14, and our upper bound is going to be 0. And we're going to plug that little guy in, and we get 0.4838. Okay, you want to bring it to 4 decimal places, please. Okay, so we want to find it to the right of z equals 0.29. So remember, it's greater than 0.29. So what we're going to do is, again, bring up our calculator, and our lower value, we're going to do second VARS, normal CDF. If we're going to the right, it's all the values greater than that. So our lower value is going to be 0.29, and our upper value is going to be infinity. So remember, we can just enter, I always told you guys to just enter like 10,000 or something along those lines. And we enter that in and we get 0.3859. Okay, so hopefully these should be, it's almost all calculator. So here, find the area under the standard normal distribution curve. So remember when we do this one, again, second vars, our lower bound is what is going to be negative 10,000. Remember how I did that? And then for our z-score, it's negative 1.39. So it's all the numbers less than 1.39, negative 1.39. Okay, so it's quite a small number, so it's 0.0822, so it's going to be rounded up to 0.0823. Okay. All right. Okay, so 98.87 of the area under the distribution curve lies to the right of it. So when we're trying to come up with area, we need the area to the left. So I'm going to do 0.1 minus 0.9887, right? And that's going to be the area to the left. So we're trying to find the z-score, right? So I'm going to do 1 minus 0.9887, and that gives me 0.0113. So that's going to be our area. So this is when we're using inverse norm and we're trying to get the z-score. So 0.0113. So again, with my calculator, I'm going to do second vars, and I'm going to do inverse norm because I'm trying to come up with a z-score. All right, so I have an area. It's always the area to the left. So it's 0.0113 is my area. And I get a z-score of negative 2.28. So z-score is equal to negative 2.28. Okay. Okay, so 82.12% of the area under the distribution curve lies to the right of it. So we have to figure out what's to the left. So again, I'm going to do 1 minus 0.8212. So I have 1 minus 0.8212, and I get 0.1788. So that's what I'm going to enter in the calculator when I do inverse norm. So second vars, inverse norm, point my area to the right, to the left of this value is 0.1788. All right, and so I plug this in, and I get a negative z-score of negative 0.92. Now, if you're going to notice, a lot of times what I'm going to do is bring the z-scores to 2 decimal places. So that's, z-scores are usually to 2 decimal places and the areas to 4. So again, one more time, we have area to the right of the curve of the z value. So I'm going to do 1 minus 0.6064. And that's going to give me 0.3936. And then I'm going to enter that into my calculator. So, second, I'm going to just go ahead and clear it real quick. So I'm going to do second vars, inverse norm. I'm doing the area to the left again, which is 0.3936. So then I get a z-score of negative 0.269. So I'm going to do negative 0.27. All right. So that's basically 6.1. 6.2 is just taking things a step further through this, and we're going to go ahead and calculate these. So the average early bird special admission price for the movie is 5.81. So that's our mean. With a standard deviation, so our standard deviation is equal to 0.81. What's a probability that a randomly selected admission charge is less than 350? So the first thing we're going to do is get the z-score for 350, and we're going to find the area to the left of it. So I'm going to do 350. So remember, our z-score is our value minus the mean divided by the standard deviation. So that's 350 minus 5.81, and then I divide that by the standard deviation of 0.81. So 350 minus 5.81 gives me negative 2.31. And I'm going to divide that by 0.81. And my z-score is going to be negative 2.85. So then I enter that into my calculator, and remember, I'm doing it to the left because it's less than. So I'm going to do second vars, and I'm doing normal CDF. So if it's to the left, my lower bound can stay right like this, which is negative infinity, basically. My upper bound is the z-score, which is negative 2.85. And I enter that in, and here's my probability, which is 0.0022. So that's our probability, 0.0022, which makes sense because it's less than this, and our mean is already 5.81, so that's really low. That's much lower than what our mean is. Okay, so the average annual salary for teachers is $47,750. Assume the distribution is normal and the standard deviation is 5,680. Find the probability that a randomly selected teacher earns between $35,000 and $45,000 a year. So we have to calculate two separate z-scores, one for 35 and one for 45. All right, the $35,000 z-score is going to be our lower bound. So I'm going to do x minus, oh, remember it's x minus the mean divided by the standard deviation, right? So it's 47,750 divided by 5,680. So if I was doing these on the calculator, I'm going to show you what I'm going to do. I'm going to do the difference first. So I'm going to do, 35,000 minus 47,750, and then I divide that by 5,680, and I get a negative z-score, which is negative 2.24. So this one is negative 2.24. So that's going to be our lower bound, and our upper bound is the between $45,000 a year. So we're going to do 45,000 minus 47,750 divided by 5,680. So 45,000 minus 47,750 divided by 5,680 gives me negative 0.48 as my upper bound. So when I enter this in my normal CDF, so second vars, normal CDF, So our lower bound is negative 2.24, and my upper bound is negative 0.48, and I'm pulling up the probability that that's going to happen, which is 0.3031. Okay. All right, so let's do a couple more. So the average monthly mortgage payment, including principal and interest, is $982. So our mean is $982, and the standard deviation is 180. What's the probability that your mortgage payments are between 800 and 1150? So we're going to do 800 minus 982 divided by 180. That's going to give me the lower z-score. So I'm going to do that 800 minus 982, and then I divide that by 180. That gives me negative 1.01. And then our other z-score is 1150 minus 982 divided by 180. That's going to give me a z-score 1150 minus 982 divided by 180. That's going to be 0.93. So then I enter that into my calculator. It's really just as easy as it gets, guys. So we have second FARS, normal CDF. Our lower z-score is negative 1.01, and our upper z-score is 0.93. So we're going to have a decent amount, I think over 60%. There you go. So it's 0.6676. Okay, so here's some compound problems that you guys are going to have to do. So the average amount of rain per year in Greenville is 49 inches. So the mean is 49, and the standard deviation is 8 inches. Find the probability that next year Greenville will receive the following amount of rainfall. Assume the variable is normally distributed. So at most, so it's going to be less than or equal to 55 inches of rain. So first thing I'm going to do is find the z-score. So it's 55 minus 49 divided by 8. And that's going to be 0.75. This is going to be our upper bound because it's at most, right? So less than or equal to. So I'm going to run that into my calculator. So second FARS, normal CDF. Our lower bound is going to be, remember I can do like negative 10,000. And then my upper bound is 0.75. Okay. And so I get 0.7734. So it's 0.7734. So 46 and 54 inches of rain. So we have to get the z-score for 46. So z-score is 46 minus 49 divided by 8. 46 minus 49 divided by 8 is negative 0.375. And then I have 54 minus 49 divided by 8. Divided by 8 is equal to 0.625. So we're going to put that into our calculator. So second VARS, normal CDF, lower bound is negative 0.375. Upper bound is positive 0.625. And we plug that guy in, and we get 0.3802. So that's 0.3802. Then if we're doing at least 62 inches of rain, we need to go ahead and calculate our z-score for 62. So that's going to be 62 minus 49 divided by 8. So 62 minus 49 divided by 8 is 1.625. This is going to be our upper bound because it's at least that much. So that's going to be second VARS. And that's normal CDF. And our lower bound is 1.625. And our upper bound, I'm just going to do positive 10,000 or more. I usually add more than one, more zeros than I need to. So I get 0.0521. So 0.05. Okay. I think this is the last one. So let's go ahead and get the z-scores for all of these first. So during the games, our mean is 20 and our standard deviation is 3. So if we have a mean of 20 and we want a z-score where it's equal to the mean, this z-score is going to be 0, right? For 25 gallons, it's going to be 25 minus 20 divided by 3. So that's going to be 25 minus 20 divided by 3, and that's 1.67. Okay, so less than 19. So again, I'm just doing z-scores right now. So less than 19, it's going to be 19 minus 20 divided by 3. So that's going to be equal to 0.33. More than 21 gallons, it's going to be 21 minus 20 divided by, so this is going to be negative, so negative 0.33 divided by 3, and that's going to be a positive 0.33. 26 is going to be 26 minus 20 divided by 3, so that's going to be a z-score of 2. And then 28, so 28 minus 20 divided by 3, so that's 8 divided by 3, and that gives me 2.67. So now, between 20 and 25 gallons, so let's go ahead and do these calculations. So second VARS, normal CDF. My lower one is going to be 0, and my upper z-score is going to be 1.67. Enter that in, and I get 0.4525. Okay? So less than 19 gallons. Remember, it's less than, so I'm going to do second VARS, normal CDF. My lower bound is going to be negative 10,000. And my upper bound is negative 0.33. Enter that little guy there. So it's going to be 0.3707. And then what about more than 21 gallons? These two should be pretty darn similar. So let's try that. So second vars. Now here we're doing more than, right? So our lower bound is a positive 0.33, right? And then our upper bound is going to be your 10,000. And I get 0.3707. Now we're going to do between 2 and 2.67 z-scores. So second vars, normal CD. Sorry, this guy like ran away from me. So second vars, normal CDF, and my lower bound is 2, and then my upper bound is 2.67. So half, oh, not 1.67, sorry, 2, and then 2.67. And then I enter those guys in there, and I get 0.0189. So that would be 0.0190. Because we got to round up. Okay, so that should give you plenty to help you with any of the quizzes and the test for this unit. Again, I've also filmed how to do confidence intervals again, so you guys should be in pretty good shape. Please make sure you get this stuff done by the 20th. Thanks a lot. Have a great day.